In the vast expanse of space, it hangs in our sky, a silent guardian, a constant companion, the moon. Our moon, for thousands of years, has been a source of wonder and inspiration, a muse for poets, a guide for sailors, and a stepping stone for explorers. We've studied it, walked on it, and even brought pieces of it back to Earth. Nevertheless, it continues to hold secrets and captivate us with its mysterious appearance. We now stand at the threshold of a new era of lunar exploration. The Artemis missions are a bold venture that promises to take us further than ever before and reveal truths formed over billions of years. Did you know that deep beneath the crater-cut surface of the moon is its solid iron core, or that there is water ice hidden in the shadows of its craters? And that's just the beginning. From stunningly detailed images revealing its true colors to groundbreaking geological discoveries, we're learning more about our celestial neighbor than ever before. Let's dive into the fascinating world of lunar discoveries. Before we delve into the future, let's take a moment to look into the past. The moon has been a part of human history since time immemorial, a constant presence in our night sky, inspiring awe and curiosity. Ancient civilizations around the world revered the moon, weaving it into their myths and legends. They tracked its phases, creating the first lunar calendars, which are still used in some cultures today. The invention of the telescope in the 17th century was a turning point in the study of the moon. Astronomers such as Galileo Galilei were able to observe the moon with unprecedented accuracy, discovering its mountainous terrain and vast flat plains, or seas as they were called. Let's go back to the 20th century, to the era of the space race. The launch of Sputnik by the Soviet Union in 1957 provoked fierce competition between the world's superpowers, culminating in NASA's Apollo program. In 1969, Apollo 11 made history. Neil Armstrong and Buzz Aldrin were the first humans to set foot on the surface of the moon, a moment that fascinated millions of people around the world. The Apollo missions brought many lunar samples and data, changing the way we think about the moon. Since then, many missions to the moon have been launched in various countries, each contributing to our growing body of knowledge. We've mapped the surface of the moon in detail, discovered traces of water ice, and studied its geology, atmosphere, and magnetic field. The Artemis I mission marks a new chapter in our exploration of the moon. Named after Apollo's twin sister from Greek mythology, Artemis carries the torch of lunar exploration into the 21st century. Launched by NASA, Artemis I was an uncrewed test flight that took the Orion spacecraft around the moon. The mission was an important step in testing Orion's systems and capabilities, paving the way for future manned missions. During its voyage, Orion flew farther from Earth than any other human-built spacecraft had ever flown. It made a 6-day voyage around the moon, collecting valuable data and testing its systems in the harsh conditions of deep space. The mission provided us with stunning images of the lunar surface taken by Orion's onboard cameras. These images not only provide a glimpse of the stark beauty of the moon, but also serve a practical purpose in helping scientists and engineers appreciate the operation of Orion's systems and instruments. After completing its orbit of the moon, Orion returned to Earth, reaching a speed of 20,000 miles per hour on re-entry into the Earth's atmosphere. The successful landing and recovery of the spacecraft marked the end of the mission and the beginning of a new era of lunar exploration. The Artemis I mission was a testament to human ingenuity and the exploratory spirit. It was the result of the hard work and dedication of countless people working toward a common goal. to return humans to the moon and one day make the next giant leap to Mars. Our closest celestial neighbor is more than just a beautiful object in the night sky. It is a treasure trove of information about the early solar system, and its geology holds clues to its own fiery birth and tumultuous history. The moon's surface is a rugged landscape of mountains, valleys, and plains, mottled with countless craters. These features tell the story of a place bombarded by meteorites and of the volcanic activity that once occurred on its surface. The rocks delivered by the Apollo astronauts told us a lot about the composition of the moon. They showed us that the moon's crust is mostly composed of a rock called basalt, formed from rapidly cooling lava. One of the most intriguing recent discoveries about the moon is deep beneath its surface in its core. For a long time, the nature of the lunar core remained a mystery, but recent research has shed new light on its composition. Like the Earth, the moon has a layered structure with a crust, a mineral-rich mantle, and a core. But unlike the Earth's molten outer core, the moon's core is thought to be mostly solid. This conclusion is based on data from seismometers placed on the moon by the Apollo missions. These instruments record lunar tremors or moonquakes, vibrations that pulsate in the moon's interior. By studying these vibrations, scientists can infer the structure and composition of the moon's interior, similar to the way a doctor uses an X-ray to look inside a patient. The solid iron core is important to our understanding of the moon's past. It suggests that the moon once had a magnetic field created by the cooling of this iron core. This magnetic field may have protected the surface of the moon from solar radiation, just as Earth's magnetic field does today. A solid iron core also helps explain some of the volcanic activity of the moon. When the core cooled and solidified, the moon had to shrink, releasing heat and causing volcanic eruptions. These eruptions shape the surface of the moon, forming its vast plains and filling its craters with lava. Finally, the solid iron core provides insight into the formation of the moon and the early solar system. This supports the theory that the moon was formed from the debris of a giant collision between a young Earth and a Mars-sized body. This violent origin would have left the moon with a molten ocean of rocks that slowly cooled over billions of years to form the moon as we know it today. As we continue to explore and study our closest celestial neighbor, who knows what other secrets we'll uncover? Every part of the moon, from its surface to its core, has a story to tell. Water. It is the essence of life as we know it. And for a long time, we thought that the moon, with its barren, airless surface, was devoid of it. But recent discoveries have turned that assumption upside down. As we know, the surface of the moon is dotted with countless craters. These places, especially near the poles of the moon, are in constant shadow, protected from the heat of the sun. In these eternally dark craters, temperatures can drop to minus 418 degrees Fahrenheit, low enough to trap water ice for billions of years. Indeed, several missions have found traces of that very water ice in them. NASA's Lunar Reconnaissance Orbiter, or LRO, was instrumental in this discovery. LRO has been making unprecedentedly detailed maps of the moon's surface since 2009, and its data has revealed the presence of ice in the polar craters of the moon. Another mission, LCROSS, Observation and Sensing Satellite, dramatically confirmed the presence of water ice on the moon. In 2009, a rocket exhaust stage crashed into a crater near the moon's south pole. The impact raised a plume of debris, which was analyzed by the LCROSS tracking spacecraft. The analysis revealed a significant amount of water ice. Although the discovery of water ice in lunar craters was a significant breakthrough, recent research has taken our understanding of lunar water to new heights. A A recent study revealed a detailed map of water distribution near the Moon's south pole. This map was created using data from NASA's Stratospheric Observatory for Infrared Astronomy Lunar Reconnaissance Orbiter, SOFIA. It shows the possible location of water ice near the Moon's south pole. The map reveals a complex picture of the Moon's hydration. Water is not evenly distributed across the south pole, but it is concentrated in certain craters and regions. Where lunar water can come from, whether it is ancient and exists by itself in lunar minerals from early volcanic processes on the Moon, or delivered by asteroids, comets, or solar winds, and whether it migrates across the Moon's surface, is another important question left open by SOFIA observations. This detailed map of the distribution of water on the Moon is not just a scientific achievement. It's a roadmap for future lunar exploration. Knowing where water is located is crucial for planning future missions, especially those that aim to ensure a sustained human presence on the Moon. Water is a valuable resource in space. It can be used for drinking, growing food, and providing oxygen for breathing. But perhaps most importantly, water can be broken down into hydrogen and oxygen, components of rocket fuel. That means that lunar water could be used to refuel spacecraft. This makes the Moon a potential refueling station in space for missions going farther out into the solar system, such as Mars. When we think of the Moon, we often imagine a barren, airless world. But did you know the Moon has an atmosphere? It's incredibly thin and rarefied, but it exists and is the subject of intense scientific research. The Moon's atmosphere is known as the exosphere, the thinnest type of atmosphere there is. It is so rarefied that individual molecules rarely collide with each other. Instead, they follow ballistic trajectories like tiny rockets. The Moon's exosphere is composed of various gases, including helium, neon, and argon, as well as traces of other elements. These gases are released from the lunar soil in a process known as degassing. NASA's Lunar Atmosphere and Dust Environment Explorer, or LADEE, was a mission specifically designed to study the lunar exosphere. Launched in 2013, LADEE made detailed measurements of the composition and structure of the exosphere, as well as the lunar dust environment. One of the key discoveries of LADEE was the discovery of a dust cloud hovering above the lunar surface. This dust rises into the exosphere as a result of micrometeorite impacts, creating a temporary, ever-changing dust exosphere. As we prepare for future lunar missions, understanding the exosphere of the Moon will be critical. It can affect landing and takeoff conditions and may even pose a hazard to astronauts and equipment. Just as our understanding of the Moon's exosphere has been enhanced by modern technology and scientific missions, so too has our ability to visualize the Moon's surface increased. In this era of advanced astronomy, we've been able to capture the stark landscape of the Moon in stunning detail, offering us a closer look at our celestial neighbor. From the earliest photographs taken by lunar orbiters to high-resolution images taken by modern telescopes and spacecraft, we've seen lunar craters, mountains, and valleys in exceptional detail. One of the most outstanding images of the Moon was recently created by astrophotographers Andrew McCarthy and Connor Mathern. This image is not just one image, but consists of more than 200,000 images taken in one evening and carefully stitched together to create a breathtakingly detailed portrait of the Moon. The entire image is assembled like a mosaic, each tile consisting of thousands of photos. This process, known as stacking, increases the signal-to-noise ratio of the image, improving detail and reducing the effects of atmospheric turbulence. The final image is a spectacular 174-megapixel masterpiece. It shows the moon in stunning detail, with every crater, mountain, and valley visible. The image also shows subtle color variations in the lunar surface caused by differences in the composition of the lunar soil. Creating such a detailed image of the moon is not an easy task. It requires not only advanced equipment and clear skies, but also a thorough understanding of image processing techniques. Each photograph must be carefully aligned and merged, which takes hundreds of hours. But the result is more than worth it. Detailed images like this one aren't just beautiful. They're also a valuable tool for scientists to help them study the geology of the moon, track changes on its surface, and plan future missions. As we look to the future of lunar exploration, one mission stands out as a beacon illuminating the path to our return to the moon. This mission is Artemis II, the next big step in our journey toward understanding our celestial neighbor and our place in space. Artemis II, part of NASA's program, will be the first manned mission to the moon in the 21st century, taking a group of astronauts on a journey around the moon. The Artemis II crew is a diverse and talented team of astronauts, including the first woman and the first man of color to participate in a lunar mission. NASA astronaut Reed Wiseman will command the mission, and Victor Glover will be the pilot. Canadian Space Agency astronaut Jeremy Hansen and NASA astronaut Christina Hammock-Koch will also participate in this historic mission. The goals of the mission are ambitious. Artemis II will be a multi-day mission. It will be a critical test of the Orion spacecraft and Space Launch System rocket, paving the way for future lunar landings. And perhaps most importantly, it will revive the spirit of human exploration, taking us beyond Earth for the first time in 5 decades. But Artemis II is just the beginning. It's part of a larger plan to establish a sustained human presence on the moon. Future missions will focus on landing astronauts on the surface of the moon. The moon is more than just a destination. It's a stepping stone, a testing ground for the technologies and strategies we need to explore the solar system at greater depth. It's a place where we can learn to live off the Earth using lunar resources to support human missions. As we stand on the threshold of a new era of lunar exploration, we're not just looking at the moon. We are looking beyond, to Mars and the distant worlds awaiting our arrival. And on this great journey, the moon is our first stop, a beacon lighting the way to the stars. In the grand theater of the cosmos, few relationships are as close and intricate as the relationship between the Earth and its partner, the Moon. This relationship, which emerged more than 4.5 billion years ago, has determined the fate of our planet and all life on it. The Moon, our constant satellite, orbits us at an average distance of about 238,855 miles. It is the 5th largest satellite in the solar system and, compared to the size of its planet, the largest. As the moon revolves around the Earth, we see different parts of its sunlit side, a cycle that creates the phases of the moon. When the moon retreats into the Earth's shadow, we witness a lunar eclipse, a spectacular event that's captivated people for thousands of years. The gravitational pull of the moon also creates Earth's tides. As the moon orbits, its gravity attracts Earth's oceans, causing them to bulge toward the moon. This bulge creates 2 tides and 2 ebbs each day. The moon serves as a shield that protects the Earth from some meteorite impacts. Many of the craters on the moon's surface are scars intended for the Earth. But above all, our satellite played a key role in the development of life on Earth. The gravitational pull of the moon stabilizes the tilt of the Earth's axis, providing a relatively stable climate for a long time, a condition that may have been crucial for the evolution of complex life. as we continue to explore the moon both from Earth and with missions like Artemis. We don't just learn about our celestial neighbor. We also gain insight into our planet, its history, and its place in space.